However, you're not going to really hear the word probability for the first quite a number of exercises, because the first thing we need to do is learn about counting techniques. Okay, and the first thing we're going to be learning about is factorial notation, which is that symbol there. No, it is not an exclamation mark. We're not in English. From now on, it is called a factorial. Okay, so here is a basic example of what a factorial does. In how many ways can 5 people form a queue at a bus stop? So you think about 5 people standing around and they're about to go, all right, how are we going to order ourselves so we're going to go onto this bus, all right? So there is 5 people. So of the 5 people standing around, we have 5 choices as to who could be the first person, okay? Once that person has been selected, we're then going to have 4 people who can be chosen for the second position. And you can probably see what's going to happen. 3 people for the third spot, and it's going to keep going down. 2 for the fourth spot, and finally there'll only be 1 person left standing there, which will have to take that last spot. They don't really have a choice, they have to be last. Okay? So that then means if we were trying to count the number of ways of putting those people in order, we would multiply all of those numbers together. So 5 for the first number of ways, times 4, times 3, times 2, times 1. That is what we've just done by putting those 5 people in order. Now that is equal to 120, if you want to type that in your calculator. But our factorial notation, that is the shortcut of writing. Instead of having to write 5 times 4 times 3 times 2 times 1, you simply just have to write 5 with that factorial button. Now, what I didn't do is bring my calculator up. They've deleted my calculator to install it again, so we're going to have to do it the hard way. Had a computer update. So on your calculators, your factorial button is the very top right-hand corner. So all you need to do is type 5 and then press that button and press equals, and it knows that it has to multiply 5 and every number underneath that. 5 times 4 times 3 times 2 times 1. Okay, so let's keep going. Factorial notation allows the user to easily calculate the number of possible arrangements when selecting all objects in order with no repetition and no replacement. Okay, so we have to use all of them. We had to use all 5 people. We couldn't use one person twice. We couldn't replace them with something else. Okay, so that's what the factorial is. Here is the basic formula in this box for the arrangement of n objects. So it's just, we had 5 before, but any n number of people or objects, putting them in order. So n factorial is equal to, the highest number is going to be n, whatever n is. Then it's going to be 1 less than that, 2 less than that, 3 less than that, 4 less than that. And you just keep going all the way down until 3, 2, 1, you're multiplying down to the number 1. So if you think of 100 factorial, that's a lot of numbers that you'd have to multiply together, and it's probably too big to even fit on your calculator screen. It might give you an error. Interesting fact is this next one here. By convention, we say that 0 factorial is equal to 1. Yes? What's convention? Oh, it just means it's theoretically, we've worked out that 0 factorial has to be equal to 1. Now, we're going to see that in action when we look at the formula. There's another formula we're going to learn about in our next lesson. But for now, the reason that works is if you have nothing that you want to put in order, so if you have nothing in your set, how many ways can you have nothing? The answer is, to have nothing is still a possibility. It is still one possible outcome in whatever your probability event is. To get nothing is still a possibility. So it is one option, and that is how 0 factorial is equal to 1. Okay? Obviously, you never go into negative numbers because we're talking about the number of things that we're putting in order. Okay? All right, so here's some calculator practice just to make sure you've all found that button there. So typing in 5 factorial. Has everyone practiced that and was able to get, what did you get? 120, because that was that one from the top of the page. Then type in 11 factorial. Yeah, so they get very large, very fast, because obviously they are a lot of numbers that you're multiplying together. Okay, now we are going to want to do some manipulating of our factorials. And so we're going to be learning about this technique here, which is called unrolling factorials. If I have 6 factorial, I don't necessarily want to have to go 6 times 5 times 4 times 3 times 2 times 1. I might not want to go all the way down to 1. I might only want to unroll it part of the way so that I can cancel it off with something else. So that's what this one is here. So 6 factorial, I can write that as 6 times 5 factorial, and I could just stop there. You see how those are the same? I mean, if I wanted to, I could also choose to write that as 6 times 5 times 4 factorial. I can basically separate it out as far as I want to go and then put the factorial when I don't want to keep going down to the 1. Yeah? Okay, so the 5 factorial there and the 4 factorial is doing the same thing. 5 factorial, I can be 5 times 4 factorial, and 4 factorial, 4 times 3. And whenever I stop, I put that factorial in the last number. Okay, so this is what you're going to have to do here. Simplify the following here by using the unrolling technique. Now, because I have a 5 factorial on the bottom, 7 factorial is bigger. What I can do is I can unroll that 7 factorial until I get to a 5 factorial, and it will help me cancel some things off. So let me show you. So 7 factorial, I could change that to be 7. Oh, no, it's jammed. Come back, computer. Oh, don't you love that? Oh, now my screen's turned off. 7, yep, we're back. Times 6 times, and I want to stop at 5 because that's what I had on the bottom. So 7 times 6 times 5 factorial. I've just unrolled a couple of numbers, and I stopped at the 5 because I had the 5 factorial on the bottom. Now, just like algebra, if you have something on the top and something on the bottom, they can cancel out. So I can cancel those 5 factorials out, and all I have is 7 times 6. They're not factorials, they're normal numbers now. And 7 times 6 is equal to 42. Okay, so don't even need the calculator. We can answer that one ourselves. Unfortunately, we don't just stay with numbers. Okay, we need to be able to do this when there is letters in there as well. So, n plus 1 factorial on the top and n minus 2 factorial on the bottom. You always want to find the bigger one and unroll it down to the smaller one. Which is bigger, n plus 1 or n minus 2? N plus 1. Okay, so start with n plus 1. To unroll it, n plus 1 will be your first number. What is the next number underneath that? What's 1 less than that? N, good. What is 1 less than that again? And minus 1. Now notice I'm not putting multiplication signs in between. You can if you want to, but it's algebra, so next to each other means that they are multiplied. Okay, and I haven't quite made it to this one yet. I'm going to have to do another one, aren't I? So 1 less than that again is going to be n minus 2 factorial. That's just unrolling the top. The bottom, I'm not going to unroll it. I'm just going to write it down. But now I have an n minus 2 factorial on the top and the bottom, so I can cancel them out. Unfortunately, there's not a lot of tidying up that can be done here. Probably the only thing that I could do to make it a little bit nicer, see how I've got an n plus 1 and an n minus 1? Anyone remember what that's called? Difference of 2 squares. So you could write that as n bracket, if I expanded it out, it would be n squared minus 1, expanding the difference of 2 squares. And then I could expand that all the way out n times n squared is n cubed, and n times -1 is -n. Okay, so just expanded it out. If there was a lot of things multiplied together, I would not expect you to multiply it out, okay? But that one wasn't too bad. Part C, n factorial over n minus r factorial. Now that r means we don't really know how far out we need to expand that one, okay? R would be how many places are we multiplying that out? We don't know, it's just giving me a letter there to use. But we can come up with a general expression here. Which one would be bigger, n or n minus r? N, because this one's got some stuff subtracted off it, right? We just don't know how many things, but this one's smaller, okay? So let's start with n. And if I unrolled it, it would be n. The next one underneath would be n minus 1. We don't know what r is yet. Let's just go with n minus 1. Next one underneath that again would be n minus 2. And we don't know how far we have to go because we don't know where r is. It could be 5. It could be 7. We don't know. Okay, so we're making a general expression here. We would unroll that all the way to wherever n minus r is. Okay? On the bottom, we still have the n minus r factorial. Okay, so that means I'm going to be able to cancel n minus r and n minus r factorial. But what is left? Obviously, I'm going to have the n minus 1, the n minus 2. I just don't know how many things I'm going to have after that. I would have the term right in front of this one. Could anyone tell me what would be the bracket that would be 1 larger than that? I kind of gave it away just then I said 1 larger.
N plus 1 minus r.
Yeah, or I would have said n minus r, because that's what I had, and just plus 1, so I want it to be 1 bigger than that one now, because I want the one on this side of it. Okay, so the last one that I would be adding would be the n minus r, but 1 bigger than that on the plus side.
Why are you adding?
Because I've cancelled that one off. I wanted to know the one in front of it, because it's always 1 bigger going that way. I want to know the one in front of it so I could say where my thing ended, where my expanding out, where it would end down here. Okay? It's a bit of a weird one, that one. Especially when you're new to unrolling and factorials. Okay. Example number 3. Into some fractions ones. Simplify each expression by using a common denominator. So just like any time when we have fractions to simplify it, we want to put them together to be one fraction. So we need a common denominator. So I don't want to have too many extra factors in there. So let's see, if I have a 5 factorial and a 3 factorial, 5 factorial is bigger. So let's unroll that till we get down to the 3 factorial. Okay? So 5 factorial is the same as 5 times 4 times 3 factorial. I haven't multiplied, I haven't done any common denominator stuff yet. All I've done is unroll that 5 factorial. Then I just want you to see, just rewriting that, I now have 3 factorial for both of those denominators. So to make those denominators the same, all I need to do is to have this 5 times 4 on that one there as well, or in other words, 20, right? Because 5 times 4 is 20. So common denominator is 5 times 4 times 3 factorial. The first fraction already had that, so its numerator, the 1, doesn't need to change. But the second fraction I had to times by the 20, so minus 20. So okay, me putting those fractions straight together like that? Great. On the top, 1 minus 20 is minus 19. On the bottom, now that I'm kind of trying to simplify this back for my solution, I want to write this in as neat a way as possible. I don't want to write 5 times 4 times 3 factorial. I want to roll it back up to be 5 factorial again. Okay, I only unrolled it to help me find that common denominator. But the most simplified solution is always the most rolled up one. Yeah? Good. Okay, and part B. Okay, again, we're going to need a common denominator. Which one's larger? N minus 2 or N? N's larger, so that's the one to unroll. Leave the 1 over N minus 2 factorial plus, now to unroll it, N is my first term. What's going to be underneath that?
N minus 1.
N minus 1, good. What's going to be underneath that? N minus 2. Should I stop there or keep going? Stop there because I now have the N minus 2. That was the same as this first fraction. Okay, so don't forget the factorial on that. And a 1 on the top. Now to get the common denominator. They both have the N minus 2 factorial. It is these two things here that are going to have to get added to the numerator of the first fraction. Okay, so that means N minus 1 for the first fraction. The second fraction doesn't need anything. It's already got all the parts on that denominator there. Nothing new to be multiplied in. And the denominator is N, oops, let me fix that. N minus 1 and N minus 2 factorial, which I'm sure you're already thinking I am going to roll that back up. But I'll do that on the next line. All right, tidying it up a bit. If I expand this out, we can tidy it up a little bit. It won't be too nice, but we can expand it and make it look a little bit better. N times N is N squared. N times negative 1 is negative N. And we have the plus 1 on the end. We can't factorize, we can't simplify that anymore, so we have to leave the top like that. On the bottom, we just want to roll these back up to be an N factorial. And that's it. Example 4, not my favorite type of question, but there's a couple of these in your textbook, okay? So, it says, find the largest power of 2 that is a divisor of 10 factorial. Now, you're going to see why these aren't my favorite type of question. To do these, 10 factorial, we need to unroll it to try and find the factors. Okay, so 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, factors of 2. Look at each of those numbers there, and we want to see if those numbers can be divided by 2. So, 10 can be divided by 2. 8, how many 2's are in 8? 2 times 2, let's actually think, multiplying by 2. 2 times 2 is 4, times 2 is? 8, thank you. So it's 3. Excuse me. 7 doesn't work. 6 can divide by 2 just once. 5 doesn't work. 4, what's 4?
2 squared.
Yes. 3 is not going to work. 2 will just be one of them, so another 2 there. And that's it. So when we look through all of those, we have 1 plus another 3, so 4, 5, 6, 7, 8. There is 8 2's that could have been divided out of that. So in other words, the largest divider is 2 to the power of 8. Okay. Part B. Let's do it again. Find the largest divisor that is a power of 10 that is a divider of 10 factorial. So 10 factorial, let's do it again. 10 times 9 times 8 all the way down. Okay, so having a look through there, can we find any factors of 10? Obviously there is one here. There's a 10. Now when we were doing the 2's, we were trying to divide each one of them. But another thing you can also do is I could say, well, the 5 times the 2 gives me another 10. All right? So I can't do that anywhere else. There is actually 2 10s that I can take out of that. So the largest divider is 10 to the power of 2. Oops. Oh, stopping again on me. It's having the first day protest. Screen's off. Screen's on. Yep, we're going again. No, we're not going again. Now, problem. One of the questions in your exercise wants you to divide something, I'm pretty sure it's 100 factorial. I do not want you to write 100 times 99 times 99. There is another way to do it, okay? The second method, though, is not always as reliable. So when they are small factorials like this one, this is the best method to use. But for large factorials like 100, here is an alternate method. Let's go back to part A. What you do, and it seems a bit counterintuitive, but if it's 10 factorial, you just go 10 and you divide that factorial, whatever the number is, you divide it by the thing the number of factors you're trying to find out of it. Okay, so 2 is what I'm trying to find as a factor out of there. Now 10 divided by 2 goes 5 times and no remainder. Goes exactly. Then what you do is you start with that number 5 and you do the same process again. I'm going to take the 5 and I'm going to divide it by 2 again. Now that goes nicely twice, and I have a remainder of 1. We always, if there's a remainder, you just omit it, you delete it, okay? So we say omit remainder. Take that number again, 2, divide it by 2 again, which goes nicely once with no remainder. Okay, and then I would need to, just to show, I would start with the 1 and I divide it by 2, which does not go any times, and I would omit that extra 1 that was there. Okay, and when you count through there, if you add those together, 5, 6, 7, 8, there it is, it told me the power. Those numbers there, if you add those numbers there together, tells you the power of your 2 that you've been able to divide out. Okay, so highest power is 5 plus 2 plus the 1 plus the 0, which is equal to 8. So therefore it's 2 to the power of 8. But like I said, only use that for your big factorial numbers. Okay, so 14A, there's your first exercise. The ones that have stars on them are interesting, challenging questions. Okay, so I would expect that everybody should be doing the ones up to 10B here. Those of you who love the extra challenge and really want to push yourselves, you might want to have a look at the 12 and the 13 as well, but they are not the kind of questions that I'll be putting on your tests. Okay?